Hello, and welcome back on your mathematical journey. So I'm going to follow up on our solving equations with variables. And so I have a couple more examples here that are a little more complex than the ones we looked at in a previous video. The first thing I want to say before I go on, though, is that the method I'm using here is not the exact method that you always have to follow when you're solving these problems. There are often multiple routes to the same correct solution. As long as you are applying mathematical principles, in particular of equality, where if you're applying something to one side of your equation, you apply it to all terms and both sides of the equation. The order is not as important in that case, but there are certainly some paths that might make your life a little bit easier as far as computation goes. And I'll show you a couple examples here first. So first one we have here is 2x minus 5 equals to 11. Now remember from the previous video, our goal here is to mathematically retrace our steps to sort of get back to what this number x is going to represent. And so if we look at this, right, one thing that we notice is that we ended up subtracting 5 from a quantity related to x. So the first thing I'm going to do in this case is I'm going to add 5 to both sides of this equation. And let's see where that gets us. Right, on the left-hand side, we have a 2x minus 5 plus 5. So these are going to sort of cancel out, but we're still left with this 2x over here. So we'll just reduce the left-hand side to 2x, keep the equals, and then on the right-hand side, right, 11 plus 5 is just going to be 16. Now notice at this point, to get this x by itself to mathematically retrace, right, we ended up multiplying it by 2 here. Remember, the mathematical opposite of multiplication is division. So I'm going to rather divide both sides by 2 here. Let's see what that gives us, right? Over here we have 2 divided by 2, which is 1. So we have 1x on the left-hand side, which I can just write as x. Then we have an equals here, and then we have 16 divided by 2, right, which is going to give us an answer of 8. So it looks like we got an answer of x equals 8. We can always go back and plug in 8 for x here and make sure equality holds, right? 2 times 8 is 16. 16 minus 5 is indeed 11. So x equals 8 looks correct. And once again, you could have divided everything by 2 first and then ended up doing an addition. That way would have just led to some fractions in this case, but assuming you did all the computation correctly, you would have gotten back to x equals to 8. Now let's take a look at the second example. We have n plus 1, and we're going to take this entire quantity and divide it by 4, and that's going to get us to 3. So if we want to mathematically retrace our steps here, I'm actually in this case going to multiply both sides by 4 first. The reason being is that if we wanted to perform, let's say, a subtraction first, you noticed this n plus 1, we would need to do something called distributing, and in this case we'd actually be distributing a fraction. We would have to distribute a fraction of 1/4 to each term inside the parentheses. So, rather than doing that, I can just instead multiply both sides by 4, since that's the opposite of dividing by 4. So we can say this times 4 and this times 4. Right, we have a 4 times 4, which remember from our fractions, right, we could say this is 4 over 1, right? And if we're multiplying fractions, we can cancel out this 4 and this 4, which will give us a 1 and a 1. And so now on the left-hand side, we're just left with this quantity n plus 1. And on the right-hand side, we just have 3 times 4, which is just going to give us 12. And now at this point, we have n plus 1 equals to 12. We've done most of the hard work. The last step we need to do here is just subtract 1 now from both sides so that we can mathematically retrace our steps. The opposite of adding 1 would be subtracting 1. So we will subtract 1 from both sides. The plus 1 and the minus 1 will cancel, so we'll just be left with n on the left-hand side. And we have a 12 minus 1 equals to 11 on the right-hand side. So it looks like we've gotten the answer, n equals 11. We'll just quickly double check, right? 11 plus 1. Remember, order of operations, we do parentheses first. So 11 plus 1 is 12. 12 divided by 4 equals to 3. That was our original equation here before I modified it on the board. So it looks like n plus 11 is correct in this case. And once again, you could have distributed the 1/4. And assuming you did everything correctly, you should have also gotten back to n equals to 11. I hope that helps. If there's any further questions, feel free to ask in the comments and I will get to them. Otherwise, happy mathing and enjoy your day.